Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 9 of lesson number 11, Work and Energy. So in this part, we will be studying more about potential energy. We'll be discussing some of the real life activities because the activities that we have studied in the last class, you might have observed that that was also with respect to some real life examples, right? And two more activities that we are left with now, they are also somewhat related to the real life examples as well, right? So we'll be discussing on that, and after that we have one more concept to discuss, that is potential energy at a height. And then we have conservation of energy, then we have rate of doing work, and these are some of the subtopics that we are still left with for the lesson work and energy, right? So maybe today, like in the next part or next to next part, I'll be ending up with the lesson work and energy. So it means we have only one or two more parts, right? So make sure you keep on revising each and everything so that when I finish the lesson, when we discuss about the exercise question, every one of you are ready to write the answers of your own. If you remember in part 1, I might have told you to write whatever information you have on work and energy, right? So in part 1 you did that, in the last part also you will be doing that. So you will get an idea of what additional parts you have studied, and now I guess you will be able to write 2-3 pages on work and energy, because there are so many concepts, there are so many activities that you have studied. And if you write like four lines each on on each activity and on each subtopic, you will be easily able to write one page, right? One or two page. So you have to be that much thorough with the lesson because we are revising it. I'm making you revise from your notes, I'm making you revise from the screen, so I'm helping you in whatever way is possible for me, and I'll help you ahead as well. So make sure you utilize whatever information has been provided by revising it all again. Okay, so before I proceed with this part 9, I want each one of you to please revise all the notes that you have in your book, starting from part 1, because part 1 was more informative and elaborative as well. Because in part 1 we discussed about all the basic concepts and work and energy. So now your revision is going to be different. I hope you know how you have to do the revision now. You just have to see that subtopic or question that you have written for your notes, and you should be able to answer them confidently, and that is how you will have that confidence in you that you know about this lesson work and energy. Okay, so I want you all to have this confidence within you all. So come on, quickly revise each and everything that you have written, and as I said, do the revision same way. Okay? So now I'm going to show you the slides one by one that we started with, and the first thing that we started is with respect to work, right? So the first subtopic that we have is not much work in spite of working hard. So over here on the slide, if you can see, we have different examples given. Like we have the example on Kamli, where she's preparing for exam. She's spending so much time in studies, and she's reading book, drawing the diagram, organizing her thoughts, collecting the question paper, attending classes. So she's doing so much work according to her, right? But as you know, that scientifically the definition of work is quite different, right? If I'm just speaking and I'm sitting at one place, it means I'm not doing any work, because when can I say a work has been done? If a force has been applied on an object. And second scenario, second case that you should be like taking to judge whether work has been done or not is whether there is displacement or not. So if I'm sitting at one place and if I'm just teaching you all, is this a kind of work scientifically? Scientifically it's not work, right? So this is what you need to understand, and you have to be like so much confident that you can explain this in your own words. Okay, so I want each one of you to please go through this slide properly. You should be knowing the examples, okay, so that you can elaborate your answer. So instead of going through it, make sure you just close your eyes and say the answer to yourself. What if I tell you to write some points into this heading, not much work in spite of working hard, what points you can come up with? Okay, I hope every one of you are going through the slide. After this, we discussed on this activity 11.1. So I want each one of you to please go through it as well, and whatever question mark has been given, you should be able to answer it as well. Okay, so make sure you're going through it, everyone. After this activity, we discussed on the scientific conception of work. So over here we have the two conditions which needs to be like satisfied, and then only we can say that the work has been done. So the first situation or the condition that they gave is a force should act on an object, and the second condition is that the object must be displaced. So when these two conditions have been satisfied, then only we can conclude that the work has been done. Okay, so please go through the slide, everyone. After this, we discussed on this activity 11.2, where you can see like there are so many question marks that have been given, so you have to answer them. This is the type of revision that you need to do, and please be quick with your revision, everyone. After this activity 11.2, we discussed on activity 11.3, where you might have written some of the you can say some of the situations, right? So I want each one of you to please go through it quickly. Then after this we discussed on work done by a constant force, and I want each one of you to please go through this slide as well, as this is an important slide again, because the formula for work has been derived over here, which is equal to force into displacement. Okay. So please go through it, everyone. After this, we discussed on some more important concepts with respect to work. So I just want each one of you to please go through it quickly. Then we discussed on this example 11.1, and I want you all to please go through it as well quickly. Then after this, like here we have brief explanation on it. So please go through it as well again, everyone. After this, we discussed on activity 11.4. So I want you all to please go through it again as well, everyone. After this, we discussed on this example on how can we calculate the work done, right? So for that, we have this example 11.2. So please go through it as well, everyone. So you can get this kind of numericals in your exam as well. But the one that has been given over here is very easy because like they have given you the mass and the displacement, and you know that work is equal to mass into displacement, right? So that is the reason like you'll feel it more easier because it's a very direct question. So it's just that if you know the, if you know the, you can say formula, you can easily solve it. And you need to make sure that you're writing the proper unit once you calculate the answer. As you can see that it has been stated at the end that work done is 225 joule. So either you can write joule or you can write newton meter. Okay. Then we discussed on energy, right? So I want you all to please go through it quickly as well. I hope you all are going through it because like over here we have one of the important, you can say, statement that sun is the biggest natural sources of energy for us, right? So please make sure that you go through it properly and you know the concept. I don't want you all to rectify it. You need to study the concept, okay? After this, like here we have more information on energy, where we have the exact definition, like the scientific definition of energy, as well as the unit that we use to explain, to indicate the energy. Everything has been given over here. So please go through it, everyone. Then after this, we discussed on this activity 11.5. Please go through it as well, everyone. Then after that, we discussed on the forms of energy, and I want you all to please go through it as well. Then after forms of energy, we discussed about James Prescott Joule. So I want you all to please go through it as well. Then after studying about Joule, we discussed about the kinetic energy in detail. So please go through this slide as well. After this kinetic energy, here we discussed on how can we derive the equation for kinetic energy, which is equal to half mv square, right? So please go through this derivation part as well. And as I'm telling you that you can be asked to derive this, and this is one of the most important question of deriving the kinetic energy. Okay. Then we discussed on kinetic energy in detail, and I want each one of you to please go through it as well. Then we discussed on this activities So quickly go through the activity so that we can start with the further part. And you need to go through the observation, explanation and conclusion. Okay? Then we discussed on this activity 11.7. Please go through it as well, everyone. Then we discussed on this example 11.3 as well. So I want you all to please quickly go through it as well. Then we discussed on this activity 11.4 as well. Please go through it. Then we discussed on potential energy. So everyone please go through this as well. So after discussing on that, we have discussed on this activity 11.8 and 11.9, right? So we'll be doing the further part as well. But before that, please go through it, everyone. Like whatever observation, explanation, and conclusion that you have written, I want you all to go through it. Then after this, we discussed on this activity 11.9 as well. So please go through it as well, everyone. I hope you all are going through the observation, explanation, and conclusion for it. And then we discussed on this activity 11.10 as well. So please go through this as well, everyone. So this is the easiest activity according to me, right? And this is based on real life example. That is very important. Then now we have this activity 11.11 to discuss. See, what's there in this activity is lift an object through a certain height. The object can now do work. What the object will do? The object can now do a work. So it begins to fall when released, right? So if you are lifting an object and taking it to a certain height and then you are making it fall down, in that case it's going to do some work. So this implies that it has acquired some energy, right? What it implies that it has some energy in it, and if raised to a greater height, it can do more work and hence possess more energy. So if you take it to more height, what can happen? So sorry. If you take it to more height, it can like do more work. Okay, so if you want that an object should do more work, it means you have to take it to greater height. So in that case, the potential energy will get converted to kinetic energy. But the question comes over here. Now I already told you the answer for it. The question is, from where did it get the energy? Think and discuss. So as you have already studied, like in this observations I have told you in explanation part, that when you take it to a height, it has some potential energy which is already been stored in it, and as soon as you make it fall, that potential energy gets converted to kinetic energy. Okay, so in the above situations, the energy gets stored due to the work done on the object. Because we are doing some kind of work on the object, the energy gets stored in that, and the energy transferred to an object is stored as potential energy. So as I told you, that when you take it to a height, you're doing some work on that, right? So the object has some stored potential energy in it, and if it is not used to cause a change in the velocity or speed of the object. So you transfer energy when you stretch a rubber band, and that transferred energy to the band is its potential energy, right? Same way, while you do work, while winding the key of a toy car, the energy has been transferred, right? The potential energy gets transferred to kinetic energy. So the energy transferred to the spring inside is stored as a potential energy, and the potential energy possessed by the object is the energy present in it by the virtue of its position or configuration. Whenever it comes to potential energy plays a very important role with respect to its position, because The definition itself of potential energy is energy possessed by the respective body mainly due to the change of shape or position is known as potential energy, right? So I want you all to write for this activity how exactly the potential energy is getting transferred to kinetic energy and how exactly it works. I hope you all have written all the important points from the screen. Now we have activity 11.12. See, what you need to do is take a bamboo stick and make a bow as shown in figure 11.6. So this is how you need to make a bow and like arrow. Okay. So place an arrow made up of light stick on it with one end supported by the stretch string as the same way shown in figure 11.6. So you have to keep the arrow as such that it gets like one end of it gets a support. Okay. And then stretch the string and release the arrow. What will you do? You're going to stretch the string and you're going to release the arrow, and notice the arrow flying off the bow, and notice the change in the shape of the bow as well. So you can see like when the bow was like supported from its one end, there was some potential energy stored in the bow, and because now the changes the shape of the arrow is changing and the bow is changing, we know that potential energy is getting converted to kinetic energy when you throw off the arrow. Till the arrow is positioned near the bow, Okay, it has potential energy stored in it, and as soon as it has been released, what happens? All the stored potential energy gets converted to kinetic energy. So this is how it works. See, the observation is going to be the same. Okay, where the stored potential energy is going to get converted to kinetic energy. Okay, so please write for this as well. Sorry. So I hope you all are explaining this in your own words. Then this is a huge concept. I won't start it now. So after this, the next topic that we need to discuss is potential energy of an object at a height. And we already discussed today that if any object is at a height, it means more work will be done by that object. So we'll be discussing that. Then after that, we will be discussing on many different examples and activities. So as you can see, there are two examples after discussing that. Then we have another subtopic as whether the forms of energy that we have are interconvertible or not. Can we convert one form of energy into other or not? So we'll discuss that. Then after that, we have this activity 11.13 to discuss, 11.14, and then we have this law of conservation of energy to discuss in detail, where you will be even coming up with another formula, okay, where conservation of energy is equal to kinetic energy plus potential energy. So we'll discuss that. Then after that we have activity 11.15 to discuss. Then we have like rate of doing work, we'll discuss on that. Then we have activity 11.16 to discuss, where we will be discussing more about power. Okay, then we have again an example to discuss, and we'll be going through how we can exactly solve this example. Then again we have example 11.8, we'll be discussing this. And at the end, the last topic for the lesson is commercial unit of energy. So we will be doing this as well. And after discussing this commercial unit of energy, we have the summary discussion for the whole lesson, that is work and energy. Okay. And after this summary, we have few exercise question, like altogether we have 21 exercise questions which we will be discussing. So I'm going to show you the like one by one to you. Please go through them thoroughly. I hope you all are going through the question that I'm showing you all. So this is the last question that we will be discussing for the lesson work and energy, and this is how we are going to end up with this lesson. And make sure you all keep on revising each and every concept that we have studied so far, okay? And much of the concepts are already clear to you just by having a discussion on them, right? So I will be continuing with the rest of the part for the lesson in the next part. Thank you everyone.